Good evening, ladies and gentlemen. Welcome to TechGig webinar series, an endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our performances and growth as professionals. With this principle in mind, TechGig has initiated a series of webinars conducted by industry experts to get a crisp insight of various domains across IT industry. Today's webinar is ninth in the series and will throw light on virtualization and cloud computing. Our guest speaker for today is Mr. Rayoman Gagrat, Deputy General Manager Technology at Times Group. Mr. Gagrat has over 10 years of experience in the IT industry and has worked predominantly with internet portals, developing, maintaining and managing data center infrastructure, servers, networks and storage, as well as enterprise IT. I would like to inform you that this presentation will continue for the next 45 minutes and your questions will be taken in the last 15 minutes. Meanwhile, you can post your questions on techgig.com or through the chat available in the webinar software. I would also take this opportunity to make a few announcements for our users. We are currently running the biggest online programming contest in India called the Great Indian Programming League, in which you can solve simple puzzles and win exciting prizes daily. Please log on to techgig.com/contest for further details and participation. Now, without further ado, I introduce to you our guest speaker, Mr. Rayoman Gagrat.
All right, thanks, Oliver. Hello, everybody. I hope you can hear me. My name is Rayoman Gagrat, and for the next hour, I'm going to run you through a brief introduction onto virtualization and cloud computing. So let's start by a simple mantra saying virtually anything is possible. And when we say this, mean it literally as well as figuratively, that you can achieve anything virtually. All right. So let's start with the first basic, that is I'm so sorry, just give me a moment. What is virtualization? Well, a simple technical explanation of this would be virtualization is the creation of a virtual instance of something such as an operating system, a server, a storage device, or a network resource. I mean, if you've worked with Windows as an operating system on whether it's a desktop at home or a laptop, and you created a C and a D colon partition, that's when you split your hard disk into two partitions, you've possibly achieved the most basic type of virtualization. And I'm so sorry. This is the most basic and key way to say that this is virtualization. So let's go forward and work on operating system virtualization. Is the use of software to allow a piece of hardware to run multiple operating systems images at the same time. And this technology dates back to the late 80s, where IBM came up with a technology called LPAR, wherein they had these high-level enterprise servers, which let you, break and configure servers, make them smaller, multiple servers. Okay. What is virtualization? Let's take it a little bit further. There are three main areas of IT where virtualization is making major inroads and has made quite a bit of inroads already. So the three basic types are server-based, storage-based, and network-based. Well, there are a lot of misconceptions about virtualization, and you can very easily say that virtualization is, and the general principle is that virtualization is the splicing of a single large resource group into multiple smaller resource groups. However, this is not all that virtualization is about. Virtualization works in the reverse also, where you can take multiple smaller machines, combine them with software, and you get a larger resource group, a single huge entity. A basic example would be, say, supercomputers, which in the past have been very prevalent and are a good benchmark to say that that is also virtualization. So getting further, we ask that why do we need to virtualize? I mean, traditionally, you have servers in a data center, or be it in your IT departments of servers, physical servers which are connected, they perform well, the tried and tested method. And so why do you need to virtualize it? Virtualize is a question which a lot of people generally do ask. Well, the most simple basic answers are cost effectiveness, and judging by this, I can say from personal experience, if you virtualize, you end up saving a lot of money over a long period of time. And these and depending on the scale of your setup, I mean, in large organizations, there are instances where people have saved up to, like, say, 1,000% of their spending. And what they generally did on every year on IT has come down considerably. They're saving 1,000. A very average benchmark would say 200 to 300% is the bare minimum that you end up saving, because you're utilizing less space, you're utilizing less power. So that makes virtualization extremely environmental friendly, and it provides you, there's operational efficiency is a key factor of this, because you have a single console where you can monitor, create, delete VMs, and play around with it a lot. So it's a single window implementation, which is extremely key and makes life for system administrators like me very, very simple compared to the earlier traditional methods where I give a simple example is that today if I need to deploy a machine, all I need to do is a few clicks, and within a matter of minutes I can have a ready-made machine, with how much of a CPU, how much of a memory, X number of disk space, X number of NICs, and I can have it ready within minutes and a few simple clicks, compared to the traditional method where it would take hours, sometimes even days. And a basic Windows server installation takes anywhere between 2 to 3 hours on an average, whereas this in the new in a virtualized environment gets reduced to minutes. All right, and of course you can have it's manageable heterogeneous environments, in the sense that today you can virtualize not only your live production sites, but you have a testing environment, you have a staging environment, you have a QA QC environment. You can merge all of them into a single window, and you can run it extremely heterogeneously. You can have multiple operating systems running on the same machine. All right. Going forward, I'm going to speak largely about server-based virtualization, because this is the most prevalent type of virtualization. Maximum inroads have been made in this sphere. So I'm sorry. We can just give me a minute, guys. All right. Literally speaking, you can say that this is the core of virtualization, since this is where you virtualize or splice your CPU cores. However, it's not only your CPU cores, but also basic elements of your hardware such as memory and disk space which get virtualized. This is the most common and prevalent method of virtualization. This is currently in its third generation of development, and going forth I'll of course be speaking about cloud computing, but virtualization provides the backbone of cloud computing. We'll get into cloud computing a little bit later. There are different types of virtualization, such as full complete virtualization, para-virtualization, and emulation. Where full virtualization is is the technology where you completely virtualize your hardware, and the entire onus of virtualization comes onto your virtualization software or hypervisor. Hypervisor is something I'll get into later. Whereas para-virtualization is a slightly older method of virtualization now, where partial resources is handled by this virtualization software, and partially is handled by your base hardware and operating system. And emulation, of course, a simple example of emulation is if in the good old days Mac had a product called Virtual PC where you could run Windows XP as a small application within Mac. So, and that's a very basic example of emulation, but this method is no longer much prevalent and hardly being used now. So we're coming down to most common examples and most well-known examples of virtualization software companies are, of course, VMware. There is Microsoft Hyper-V. There is Citrix with Zen Server. There is Red Hat has a product called RHEV. And these are the most common virtualization software companies. I guess between VMware, Microsoft Hyper-V, and Citrix Zen Server, you could easily assume 80 to 85% of the virtualization industry runs these three. And they've been doing it very well, and a lot of inroads have been made over the years with the software. Coming forward, I'm sorry, just give me a minute. Oh, this stuck. All right, this is a small diagram representing the two different main types of virtualization. That's para-virtualization and full virtualization, wherein the example over here is, if you see the bottom layer, the MMU is your hardware. That's the server, the physical server, which has a CPU, memory. This space, of course, we'll get into later. And well as, so there's a layer, like in this case, the Zen VM, which is virtual machine monitor, the Zen hypervisor, on top of which lies the guest OS. And so this is para-virtualization, where there is not much offload onto the direct hardware, considering that all read writes, operations, everything is taken back to your hardware resources, and the software, all it does is doing a basic validation based on the rule sets that you applied to it. Coming to full virtualization, this is the main one, where your hardware is completely segregated through the software layer from your virtual machines. Everything is handled by the software, by your VMM. This is what provides. There's a lot of rules which can be applied. There's a lot of different methodologies which you can apply in this, and going forth, this is at the heart of the server-based virtualization lies the hypervisor, which is the code set, the actual code set which handles virtualization, which takes your physical resources and contains efficiently the like I have said, the hypervisors are very minimal in size. They're hardly 700 MB to a GB in most cases. Of course, they do tend to look bigger because the hypervisor comes with a service OS on which the hypervisor is based, which is a service console also it's called. These kind of, you can say, work to around 4 to 5 GB with various vendors, but predominantly they're just a service console. So it's just a console where if you need to log into and run certain hypervisor related commands, so it provides you that interface. All right. But the key thing is your hypervisor. In fact, now there are certain companies where you can actually, if you have a USB port on your server, you can load your hypervisor on a USB port and run virtualization through that. So it's extremely flexible and extremely easily manageable. All right, so the best part about virtualization and full virtualization especially is that you can do resource allocation such as CPU, memory, disk space. It can be done on the fly. In fact, most latest operating systems, you don't even need to shut down your virtual machine. I could just go in the back end and say, suppose I wanted to add 2 more cores to an existing virtual machine. I can go in the back end, suppose it's existing 2, I can add 2 more, make it 4. I can add 4 or 5 GB more memory, and of course disk space, and everything can be done on the fly. With predominantly, I'm going to use the example of Red Hat and Windows. When the latest of versions of their operating systems, it can be done while the machine is still online, and an end user would never realize it. You wouldn't be even able to see the difference. And so suppose I'm running out of resources, I can immediately go and in a matter of seconds literally increase CPU, increase memory, and that gives extremely flexible environments to companies so that you can optimize on resources. So suppose a good example is you're running a website, and you suddenly suppose you're running a news website and there's been an earthquake or there's been a certain death or something, and you suddenly realize there's going to be a lot more traffic coming onto your website, and you require more resources, so you need more CPU, you need more memory. You can do it on the fly, while the site's being updated or while people are accessing it, and you would never come to know. All right, but however, everything is not hunky-dory, and when it comes to reducing resources on VMs, so like suppose I have increased this, and the most prevalent problem is with disk space. Disk space, once added and once utilized, I may empty out and free out the disk space, but I cannot reduce the disk space in virtualization. Most vendors claim that it does work, but a practical scenario isn't very prevalent where actually you reduce the space in a VM. But these limitations do not exist with the virtualization software. They're more to do with the operating system, with the operating systems that are there out there. They do not let you decrease the space while you're in production. So this is one drawback that is there, and it's a pretty serious drawback. If that is, it can impact you in terms where you have limited space and you need to optimize on space, so you got to be careful before increasing space. And a simple fact is that server-based virtualization helps IT managers reduce deployment from weeks and days to literal minutes. I mean, I can give a practical example where we have a template for a virtual machine which is approximately 8 GB in size, and if I need to give a VM to my application team and they want a fresh OS install, it takes me hardly 2 to 5 minutes to deploy a 6 GB VM. Of course, deployment times predominantly vary with the size of the VM. So because a VM in the background is actually a folder which is created on your storage, to explain it in bare simple terms. And so the larger the size, of course, is going to take that much longer to copy and deploy. So suppose a 100 GB VM is going to take you, say, 30 minutes, but traditionally speaking, I have a VM, the OS gets corrupted for some reason, which is a very common scenario. Earlier, you would have to go back, reinstall the entire OS, reinstall all the drivers, reinstall your app, reinstall all your settings. Whereas today, if you're running a virtualized environment and you have a template ready, wherein you've already done your OS level settings, you've installed your application, you've done your application level settings, you can have a new instance in a matter of minutes, literal minutes. So let's look at there are certain key real benefits of server-based virtualization. Of course, there's a lot more. Certain key benefits are high availability. If you run a virtualized environment, which is and you need it highly available. So, it's not, what's happening is now A VM doesn't really have to, is not completely dependent on the back-end hardware. I could, if you're running high availability, you can actually, your VM, if your physical server goes down, it moves on to another server. That's it. It's as simple as that. And it's so easy and transparent in the background that nobody would actually even realize that a VM has actually failed over from one host to another till you actually go and see it. Of course, another key benefit is cloning. Like I've just explained some minutes back, that you can, if you have an existing VM, you can deploy it, you can clone it. So like I gave with the example of increasing resources, when I don't want to increase resources in my VM, but I want a complete new application server. A good example is taking an application server. I want one more instance of an application server which I'm going to run temporarily because my load is temporary. You can take an existing application, clone it, and again, based on the size of the existing VM, the clone VM gets created max to max 1 hour. So of course this provides tremendous flexibility, and if there are any sysadministrators here, you will understand what I'm trying to say, compared to that I need one more server. Of course, it's going to take me 2 to 3 hours on an average to deploy one in the traditional environment. Of course, another key benefit over here you can see is overcommit. Overcommit basically is a simple explanation, is that suppose I have a server with 8 cores of CPU, say 64 GB of RAM, and I want to create more VMs, or I need certain temporary VMs, and there is no hard and fast rule that all at any given moment of time, whatever VMs you have created are using all the resources. So there may be certain VMs which may be using more number of CPU. There are certain VMs which are using more amount of RAM. However, I can actually, like say, almost double, based on how my environment is, double the number of virtual resources. So, and this gives you the complete flexibility of taking care of matters, like I said, of sudden load coming in, or having an environment where I have limited resources but I need to portray it as more. Alright, so an overcommit is an extremely key feature. Also, from the from a hard disk perspective, there's a new feature called thin client provisioning, and this is predominantly a VMware concept where I give a VM, say 60 GB, I allocate 60 GB of data to a particular VM. However, I've allocated 60 GB, but I'm using initially only 10 or 12 GB. And what happens with thin client provisioning is that as and when I write data to the VM, in the physical backend on the storage, it starts populating and it starts increasing in that manner. So I could actually have 200 GB of data space in the background on my storage, and I could allocate, like, do an overcommit of say 300, 400 GB. Of course, you have to be very careful, because if you do run all your VMs start writing together, you are going to run out of space. But this lets your storage get utilized more systematically, more efficiently. It provides you the flexibility of increasing and utilizing resources to the most optimal manner, which of course you would never get if you were using the old environment of simple rack-based servers. Of course, now when you come down to server-based virtualization, there are a lot of key parameters that you need to consider when you're planning a virtualized environment, or you're going to implement virtualization in your environment. Of course, virtualization traditionally impacts medium and large organizations. A really small organization, if you are a less than 10 server setup, virtualization gives you absolutely no benefit. It would be easier and cheaper for you to go back to the traditional method of having pure servers. Whereas in a large organization, something, say, suppose the size, an organization having 80 servers to, thousands and thousands, which certain large organizations have, virtualization plays a dramatic role in these environments. All right. So of course, when you're planning a virtualized environment, what are the key factors that you need to look into? Well, the most important and basic things are CPU and memory sizing. All right. How do you go about CPU and memory sizing? Of course, it's a very individual thing. Every setup is individual in its own way. Every application is individual in its own way. So how you need to size, how big a server do I need to take? So do I take a 6-core 4-server machine with, say, 128 GB of RAM, or do I go slightly smaller quad-core servers, 2 processors, 32 GB RAM? Of course, a very individual. It's a very individual and pragmatic approach, but it's a key an element that needs to be considered, because of course if you have fewer resources, you're going to get less number of VMs. That means more physical resources required to run a larger number of VMs. There's a cost involved to it, and of course if you oversize, you're running the risk of an environment where there are too many VMs on one physical resource. What happens in the case that physical resource goes down? So how do you manage that? So of course this is a very key parameter. A common mistake made while considering or planning virtualized environments is NIC cards, NIC cards on your servers. Most vendors suggest that you take a gigabit card per VM that you are using on the server. So suppose I intend to run 4 virtual machines on a server. You look at 4 NIC cards, you're going to look at 6, then you need 6 NIC cards. Of course, now with the advent of high-speed NICs, in the sense that you have a lot of NICs, a lot of servers which come with 10G connectivity, you can reduce this drastically. So you have a 10G backbone at the end. You can take you can put multiple servers. In fact, we're operating in an environment where we're using 10G ports. On an average, we're using 12 physical servers and an approximate of 50 to 60 VMs per 10G port. And of course, this is a very key parameter. Also, you need to consider your application environment. What kind of networks are you using? Are you using a single network? Do you have multiple networks? Are you in the same single VLAN, multiple VLANs? So this, of course, is a key parameter which needs to be considered, very often overlooked, which leads to a lot of problems when you actually implementing your environment, and creates a lot of bottlenecks at that later stage. All right, and can take your whole project and delay it by quite some time. So this is a very key parameter. Most common misconception that it doesn't matter. Of course, it's a given that when you're doing virtualization, you have to do it on an external storage. Saying this, I say because you have software, all these softwares give you the high availability option. So take an example where I have a physical server, but I have installed and I'm running VMs from the local hard disk. Dude, your physical server goes down, your VMs are gone. They cannot fail over onto another physical resource. So a SAN is a must-have. It's a key component. The biggest mistake anybody could make is running virtualization on local hard disks of servers, is because traditionally, and I can say from experience, that when a server goes down, there's no guarantee that it will come up immediately or for a while. All right, so a SAN environment is key critical to virtualization. Of course, when you talk of external storage, uh, storage capacity planning becomes a key parameter, because the common benchmark which people use is, oh, I need 10 terabytes of data to run my virtualized environment, and that's going to be ample for me. All right, 10 terabytes of data will suit your needs. Of course, you can, with thin provisioning, you can allocate 12 terabytes, 15 terabytes, but the key factor is I/O, and traditionally this has been the Achilles heel of a lot of environments where people have not considered the I/O as a key factor in planning the virtualized environment. Uh, a simple fact is, earlier when you have physical servers, your I/O for each and every individual server was restricted to its local hard disk. Whereas in a virtualized environment, your storage is now your localized hard disk. So every VM brings in its own overhead of I/O. A lot of people don't plan for is the I/O sizing, because say suppose in a simple environment, I would not really consider I/O a key parameter, but in virtual environment you have to plan for something like, say, at least 4 to 5 times the size of your standard I/O that you're utilizing right now. Of course, network security, and this predominantly lies with a virtualized environment. You have a central console, and you have and security is a key factor for, I guess, every application in the world, with the amount of hacking and cracking that goes around. And but in virtualization it becomes even more critical, because your virtualization software and your actual hypervisor, which resides on your physical machines, is a key network element. I mean, all your rule sets get pushed through that. So if your main virtualization console gets compromised, your entire setup gets compromised. So because it's a single window and it helps in manageability and is a major asset in that manner, of course the biggest drawback is that if it gets compromised, your entire setup and environment gets compromised. All right, and another key part is access roles. Very often companies feel that it's simple, I can give access of my virtualized environment to a junior system administrator. One wrong click, one wrong command can actually bring down your entire setup, and that's a huge risk. So these are key parameters which need to be considered. Moving on from server virtualization, coming on to storage-based virtualization now. Storage virtualization, in simple technical terms, can be termed as the amalgamation of multiple network storage devices into what appears to be a single storage unit. What this basically means is that traditionally storage-based virtualization is not, you're not actually splicing your storage. It's very different from server-based virtualization, where you're actually creating multiple virtual instances of a physical server or hardware. Storage-based virtualization is at the opposite end of the spectrum, where you already have multiple storage devices, you have an environment of storage, and storage-based virtualization is simple software which helps you manage and maintain your storage setup. Suppose you have a storage setup from HP, you have an HP EVA, or you have an IBM storage, or you have a NetApp based NAS gateway type storage. Software storage-based virtualization, all it does is provide you a single interface which will help you manage all of these. So you can take multiple storages from multiple vendors and combine it into a single unit. And Traditionally, if you have multiple storage devices, they come with their own individual software. So you need to have a storage administrator who's, so suppose he's scheduling a backup on one storage, so he needs one software. He needs you need to create new partitions in logical devices in another storage, so that's a separate activity with another separate console. Storage-based virtualization provides you a single console, a single window, wherein all these activities such as backup, archiving, recovery, all these activities are done in a more easier manner, and it helps, of course, saving up on a lot of time. Storage virtualization is based again via software, and also there are a lot of new appliances in the market now. It's a hybrid hardware plus software environment which provides you storage-based virtualization. However, storage-based virtualization is still in its infancy. There's a lot of work that needs to be done in it. Same moving on to network-based virtualization. Again, this is still in its infancy stages. It's very basic. It's not as highly developed as, say, server-based virtualization is. Again, similar to storage-based virtualization, network-based virtualization is a software single window for multiple network devices. So provides you a single window to connect with various network equipments, and that's it. Please excuse me for a moment. I'm sorry. Coming back, network virtualization is very often is considered to be VLANing. VLANing, of course, is a very different methodology compared to network virtualization. Network virtualization has nothing to do with VLANing. It's a common misconception. Like I said, it's still its infancy. It's too early to say how this will go forward. There's still a lot of work that needs to be done. Network-based virtualization does not mean that if I suppose I have a firewall, I can splice it into multiple smaller firewalls and run it. Of course, there is work which is being done on that, but it's not a true form of virtualization. But this is a segment which holds most promise because traditionally servers have been your largest expenditure, and the key factor, networks, are not given their due importance. So this sphere has a lot of work that needs to be done, but again is a key critical area of IT which will be explored further. This is a simple diagram of network-based virtualization. It's a collaboration of all your applications and devices into a single window, which provides purpose. And of course, you can do network-based virtualization, helps you span across multiple LANs, multiple WANs of your organization, depending on size. Okay, now we come to the latest phenomenon and the latest big word floating around, cloud computing. The cloud traditionally is used as the metaphor for the internet. Anybody, if you ever seen a network diagram, the internet has always been represented as a cloud. Cloud computing is nothing, technically speaking, refers to the use of access of multiple server-based computational resources via digital network. What does that mean? Basically, your servers somewhere on the internet cloud, and all you need is a basic internet connection to connect to it. That's very simply put. And of course, there are lots of platforms as a service, software as a service. This is very often used to describe cloud computing because it is providing you a software as a service. I mean, you don't need to have the software installed in your machines or on your devices. It's there out on the internet, it's there on the cloud, and you can just access it whenever you want, however you want. A simple and most basic examples of a cloud-based application is your web-based email, which is Gmail, Yahoo, Hotmail, which have been around for more than a decade. I guess Hotmail's been around for more than a decade, and possibly the first cloud-based application is what you can call it. Cloud computing can be categorized into, well, three key layers: application, platform, and infrastructure. Application, or what's called as software as a service. The best example I can give you right now is GoToMeeting. What we're using right now to conduct this webinar is the most simple thing. It's where the software is based on an infrastructure on the internet. I just access the software and utilize it as and when I want and how I want it. Extremely simple. Platform as a service is, of course, when I told you virtualization forms the backbone of cloud computing, I mean it in this terms, in platform and infrastructure, where servers traditionally used, there are companies which provide you these servers. There are companies which give you the platform and the infrastructure as a service. And so these are certain examples. There's Amazon Web Services, there's Google App Engine, there's Microsoft Azure, Google new phone OS is coming, has a platform as a service it's offering. Of course, there's an infrastructure. The most common one used is Amazon EC2. All right, now cloud computing. What are there are various types of clouds out there. It's not cloud computing is an envelope which has multiple definitions. So there is a public cloud, there's a private cloud, a hybrid cloud, a community cloud, and a combined cloud. I'm sorry, a public cloud is as simple as, like, say, Amazon EC2 or GoToMeeting. It's a public cloud. It's publicly accessible to everybody. Anybody can sign up for it, pay for it, utilize it, and you're on your way and you're done. Of course, now we come to private cloud. Private clouds, generally, most companies, like I can give the personal example of my company, where we're hosting our own web services. We're not out, it's not based on anybody else's platform. We've developed the cloud ourselves, and we utilize it for our sites, like techgig.com is hosted on our own personal private cloud of the company, and we provide we manage and run the whole show. A hybrid cloud is a hybrid cloud can be termed as to certain environments where, I'll give you the best example. A public and a private cloud can be fully virtualized cloud, where everything is running on a virtualized environment, whereas a hybrid cloud is a combination of virtualization as well as traditional method of physical servers. So in our case, we have applications and front-end related applications are hosted in the virtualization environment, whereas key critical infrastructure such as databases and all, we still traditionally use old methods of physical servers connected to a SAN environment, because, well, virtualization is not wouldn't recommend running databases out of a virtualized environment. There is absolutely no issue. However, it's a personal choice, and so a hybrid cloud is a cloud environment which has a physical as well as virtualized environment. Amazon EC2 is also provides you hybrid cloud services. So you can buy processor and memory, and you can actually buy a physical server and have it all in your environment, makes it a heterogeneous environment. A basic example is that cloud computing is a software based over virtualization. It's a software over your physical infrastructure. All right, it's an environment, it's a platform which provides you, again, if you're an end user, a single window without any correlation to the back, what's actually happening in the back end. So I sign up for say Amazon or Microsoft Azure, and I say I need 20 CPUs and I need say 300 GB of RAM and so 2 terabytes of data to run my virtualized environment. Of course, I can say I want X number of physical servers also. Moving on, a community cloud is a cloud, multiple what do you say, spheres of people coming together to form a community, and they have their own private cloud. There are no good possible examples of this, and I'm sorry on that. A combined cloud is nothing but suppose I'm a big large corporate entity and I have multiple companies under me, each company having its own personal cloud. I can combine multiple clouds and make a single combined cloud, like or if I'm a single entity company which is hosting with multiple people, I could have a combined cloud environment. Like suppose I'm taking services from Amazon, I'm taking services from Microsoft, I'm taking services from Google. I can actually create a window of a combined cloud where I can manage all three together in a single window. And so that concludes this topic. I hope this has been insightful. I'm free and open to any and whatever questions that you may have.
Right now, Raymond, we will be taking the questions right now.
Sure.
Sure. Right. And we have our first question from Sanjay Verma. He says, what is a QC environment?
Sanjay, that's a very good question. I'm not the best person to tell you. QC, QA are traditional methodologies used by companies. There is the application development team which develops applications. There's a separate QA, QC team which does quality control. Basically, QC stands for quality control. So they actually verify the code that has been developed, the application which has been developed for bugs or features, and is done in that environment.
Okay. Right. The next question we have it from Revant. He says, is it possible virtualize hardware such as graphics card? Will we be able to run, say, a very high-end game using virtualization?
Personally, I can say that this type of virtualization does not exist. I mean, I am an avid gamer, and I'm very sorry, but it's not possible as yet, because most games, if you see nowadays, they require a 1 gig card to run. So where you're going to get a 10 gig card which you can virtualize? It's not done.
The next question we have it is from Rahul Rai. He says, why do we need virtualization? What is the basic need for having these layers?
Okay, Rahul, the base simple answer, and coming from an Indian company I can give you, is cost. When you implement virtualization, you end up saving a lot of money, and I do mean a lot. And so base simple answer you want is cost effectiveness. It is cheaper than traditional environments, and of course going forth, this is going to be the way forward. And if you look at not only virtualization, if you look at cloud, like a lot of all major data centers provide you cloud environments. Going forth, you use CPU and memory as you require it, as you need. So you only pay for what you need, and you don't need to have physical servers.
Right. The next question we have is from Mr. Dheeraj. He says, what do you mean by hypervisor?
Okay, Dheeraj, hypervisor is the base code which actually converts your physical resources into virtual machine. It contains the code for or control sets. Like suppose I have a 16 core CPU, I have a server with 16 cores, and I allocate 2 to say multiple VMs. The hypervisor contains the instruction sets for these VMs how to go back and use the physical resources. So it's the layer which connects your virtual resources to your actual physical resources. So this is the most critical layer of virtualization.
Right. The next question is from Mohammed Sufian. He says, will the hardware have any limit here?
There is no limit on hardware in the sense of how much hardware you can pack into a server. There are no limitations. There are, like I said, you get servers which have the capability of having 8 processors. There's servers which have up to 1 terabyte of memory can be put into them. So there is no limitation on hardware.
Now, this is from Kirtika. She says, like, what is fly?
Fly? I'm sorry, I have no clue what she's trying to say.
Okay.
Oh, yeah.
No issues. I mean, if Kirtika can be more specific on what she wants, that she can post the question once again. Now, moving on to the next one. May I know how exactly the platform and infrastructure computing will work in detail? This is from Dheeraj.
Okay, Dheeraj, okay, let me give you an example. Google's Android OS provides you a platform where if I'm a developer I can actually go to the platform, register with them, create an app right there on their platform. So I am not using my computer's resources. All I'm doing is all you need is an internet connection and a browser. You log into their platform services, you develop and write your code over there, and in fact from there you can straight away post your app onto Google Marketplace now. Similarly, Apple has a platform for iPhone and iPad devices also. I'm sorry, I can't remember the name right now. Coming to infrastructure as a service, it's a web-based portal, predominantly like say my company, Times Business Solutions. We host sites out of data centers, all right? Websites out of data centers, and traditionally we use we've used physical servers. Now we moved on to the virtualized platform. But if you're a really so virtualizing helps me if I have a slightly large, medium to a large setup. If I'm a small guy, like individually, if I had to host my own website, I could go to a site like Amazon EC2 or Microsoft Azure, and I could say I want one single server with 2 CPUs, 4 GB of memory, with say Windows 2010 operating system or Windows or Linux operating system, and I will pay as I use. So I pay on a monthly basis. Tomorrow if I need more CPU or memory, all I do is make a payment to them and I get those resources. Similarly, if I've taken more, I can reduce the number of resources. So it's a pay as you go method. So like the simple thing is this provides a extreme flexibility as a service. So your entire, or if I'm a company, I can move onto a bigger company, like say traditionally the discounts that we get when we did our virtualization environment compared to Amazon or Microsoft is tremendous. They have much larger setups, so it's cheaper and easier for them to extend those benefits to me at a smaller, cheaper rate. With that.
Right. Going ahead with the next question. Does enterprise comes under the private cloud?
Definitely enterprises do come on the private cloud. I can give a simple example is that like say there's a lot of banks like HDFC Bank, ICICI Bank, which are enterprises in their own rights, are now run virtualized platforms. I guess the best example of an enterprise could be GE, which GE traditionally had 60,000 servers running across close to 50 data centers across the world. Uh, the, the numbers come down tremendously. In fact, the numbers come down by almost, they come down almost 15 to 20 times. I'm not talking 15-20%, I'm talking 15-20 times. So that's close to like 1500 to 1000% of their entire infrastructures come down, and the physical resources have come down. Of course, more virtualized. So they have now more than 60,000 servers, but they're virtual servers. The actual number of physical servers is, say, a few thousand now.
Right. Now we move to the next question from Mohammad Hussein. He asks, I heard it is not recommended to put databases on virtual servers. Is it true?
Yes, I would say that, and if I said otherwise, I'd be lying, because we ourselves have put our databases on physical servers and not on virtual servers. It also depends on your database size. There is no difference. If you look at it as a basic end user, there is no difference between a virtual machine and a physical machine. If you look at the operating system, like, there is no difference between a 2 CPU VM or a 2 CPU physical server. So you can run databases, not recommended to run them.
Right. We have a question from Ankit Goel. He says, what will be the effect of cloud computing on ERPs?
Well, Ankit, the effect of cloud computing on ERPs is right now not so drastic, but in the future will be quite drastic, because ERPs are, again, softwares, applications which run on your operating systems. Virtualization is a layer for operating systems. So suppose you're running SAP R3, and today I need physical servers which are 4 CPU, 16 GB RAM at least. Tomorrow I could have a 4 CPU, 16 GB RAM VM, and the software would run fine. In fact, a lot of ERPs are working with a lot of virtualization companies to this regard, and of course in the future you will see ERPs moving on to virtualized platforms.
Right. This is from Deepak. He says, I need your suggestion whether to own or outsource for implementing force server new setup for SQL Windows 2008 based application for our new setup.
Deepak, very simple. Do a costing. You will get your own answer. It's very simple. Just speak to vendors, get a costing for your own environment. Of course, I would ideally suggest you move to cloud computing platform, where because of force servers, it's not worth the while. The savings are not going to be tremendous. In fact, you may end up paying more for a virtualized environment than a physical environment. So I suggest you move on to the cloud computing platforms.
This is from Sugata Chatterjee. Now she asks, like, as a user, how should I distinguish that I am on a para virtual machine or on a full virtual machine?
Sugata, in the back, as a back front-end user, you're never going to know the difference between, actually, forget a para virtualized or a fully virtualized machine and a physical server. It's only the back-end system administrator who knows the truth about it. As an end user, you're never going to know. It looks and feels and operates in the exact same way. There is no distinguishing. All the difference lies in the back end and at the sysadministrator level.
The next question from Binajin. Now the question is, for virtual machine, like, is it required to have 64-bit only? Can it be possible with 32-bit machine?
It is possible with 32-bit machines, but nobody recommends it. There are issues. I mean, the whole industry is now moving on to 64-bit standard, and it's a key prerequisite. I think 32-bit is not suggested. It's not that it's impossible, it does run, but you will face issues in a 32-bit environment.
Okay. This question is from Mohit. He says, how reliable and secure cloud computing is as compared with traditional methods?
Okay, Mohit, the simple answer is if you asked me this 2-3 months back, I got told you it's extremely reliable and extremely safe. But if you heard 2 months back, Amazon had a major issue where almost 6 lakh users were affected. They've had a major outage. But of course, that is in the back end. It's a very personal experience. I mean, we've been using virtualization for close to a year now. We've not really faced any issues. It's extremely reliable. It works fine. In fact, it's helped us a lot, made life a lot easier. But there are no foolproof guarantees. In fact, there are no foolproof guarantees with traditional environments also.
No, this question is from Sudhakar. Is security the main concern that companies are moving towards private rather than public clouds?
Security is a key concern. Now, again, when you're talking of clouds, if you look at, of course, when you're talking of infrastructure as a cloud, as a service, of course, security is an extreme consideration. But if you're looking at platform as a service or software as a service, public clouds are better. And so they do provide, because they need to provide an environment which is easily accessible from anywhere in the world as a platform. So yes, security, I'm sorry to say, is a key concern for in every sphere of IT. You know, I mean, security has to be a key concern. Very often it is underestimated and you don't realize it till it's much too late.
This question is from Ravikant. Can virtualization make a virtual HDD? In future, I mean logical HDD, for we can deploy logical HDD in behalf of physical HDD, same as for processor and other parts.
Yeah, so virtualization does predominantly work on virtual HDDs. So when you allocate space, when you're creating a VM, and you allocate space to it, it is a virtual HDD because in a perfect scenario, it's lying on the back-end storage. And it is, of course, we are moving to logical HDDs. Of course, you cannot substitute a logical HDD with a physical HDD. You do need physical resources in the back end. When you're doing virtualization, you're splicing these physical resources into multiple smaller ones. And of course, you do need a physical device at the back end.
Right. Now this question is from Nitin. He says, in your opinion, which is the best type of model to be used for small or medium or large businesses?
There is no simple answer to that because I have no affiliation to any particular vendor, but predominantly and the most common one used in virtualization is VMware. They are the most product ready as of now. The others are slightly lagging behind, but not too far.
Right. Now next question is Pawan. Do you think that in future cloud computing will finish the concept of desktop operating system? I mean to say that we'll all be dependable on service company only.
I guess that is the roadmap going forward. Desktop virtualization again is still very basic. Of course, there's a lot of work which still needs to be done in that sphere. There is a lot of work which is happening in that area, but I don't think for a while that's going to be true. But of course, the roadmap going forward is that desktop virtualization will, kill out physical desktops.
Right. This question is from Sanjay. It says, what are the risks of virtualization?
Sanjay, there are no such predominant risks, which lie with virtualization as compared to traditional physics. the risks are pretty much similar. However, the biggest risk is your planning, is how you plan your environment, what all factors have you considered into the planning of your environment, because you miss out on something or you've not planned for something, it can later impact you not only when you're going to do the actual implementation, but going forward. Like, the biggest risk I would say is sizing. You size your environment wrong, you're going to run into a lot of trouble.
Oh, the question is from Prashant. It says, what about virtual desktop VDC?
Like I said, virtual desktops are still very nascent stages. There is a lot of work happening. There is a lot of hype around it as of now. Not really there as yet, I would say, not fully ready. But I think another year or two, they're gonna be the norm in the market.
Right. Security options if we outsource to IDC as they are using virtualization. So what is the surety of data security? This is from Deepak.
Okay, Deepak, data security doesn't actually have anything to do with virtualization. Of course, your fear is that if my data is lying on somebody else's resources, and what if they have access to my data. Well, most companies, when you sign up with them for outsourcing of these environments, sign contracts with you, so you are well protected with a contract. Of course, if there's always a possibility of somebody stealing your data, but that can be an internal employee also. So there is a legal provision in the contract which safeguards your data.
Now we have a question from Geeta. She says, how can we test or install cloud computing in an organization?
Cloud computing in an organization, I think first you need to speak to virtualization vendors. You can speak to VMware, you can speak to Microsoft, you can speak to Citrix. They'll have sales guys who will come to your office. They'll sit, and in fact, before we moved on to our virtualization platform, we've done very extensive POCs with each and every one of them. We run it for months, and I would suggest that once you get a POC done, and you then move on to the platform which you're most comfortable with. Of course, cost plays a big factor, so you get down to negotiating on costing, but there is no simple answer to that. I would suggest that the best way is speak to them, call them, explain your environment, and then take it forward with them and do a POC. Most simple.
We have a question from Janil. Is there any certification course to start career in cloud computing?
Every vendor has their own certification. So like, I know VMware has, Citrix is doing. I don't have details of all of them, but each and every software provider has it. I suggest you can go look at their websites, and everybody has certification for sure.
We have a question again from Geeta. She says whether cloud computing will be available in LAN environment.
Cloud computing be available in LAN environment.
Right. Applicable. Will be applicable in LAN environment.
I think I'd like some more details. I mean, exactly what she means, because if you're talking of LAN, if you're talking of an internal organization on your internal network LAN, of course, it's extremely possible. It is, in fact, quite the norm.
This question from Narvi. She says the question here is like, are they suitable to engineering applications like AutoCAD and STAAD?
Yeah. See, like I said earlier, virtualization and cloud computing is a platform. All right. So if you look at the basis of virtualization at a server level is CPU, memory, and hard disk space, and network. So of course, your operating system comes as one add-on layer on top of that, and applications run based on operating systems. So software is the impact has more to do with operating systems and has nothing to do with virtualization.
How reliable and secure cloud computing is compared with traditional methods? This is from Mohit.
Mohit, see, cloud computing is a generic term. It's how you implement cloud computing, is how you work with a cloud provider. So, and most important thing is, like in a traditional environment, you have your firewalls, you have load balancers, you have network equipments. You can replicate the same environment with a cloud provider, and and the only difference being that you're not buying physical servers, or actually with a cloud provider you can take physical servers, or you can just buy CPU cores and memory. You can have the exact same network security setup that you have in your setup with a cloud vendor.
We have a question from Makrand. The question is there any redundancy for VM servers?
Like I explained in the point of high availability, it's a key feature of virtualization, wherein if you're running on a SAN, if you're running your setup on a SAN environment, your VM moves from one physical resource to another, and you'll never come to know also.
The question is from Dharmendra Shah. How can we virtualize USB device in Hyper-V? Like USB dongle.
I haven't worked extensively with Hyper-V, so I'm sorry I can't answer your question, but if you go to Microsoft's knowledge base, I'm sure you'll get an answer from there.
Right. There's one more question from Dharmendra. He says, as the SAN is key component of virtualization, how do we consider virtualization as cost effective, especially if an organization does not have an existing SAN?
Right, Dharmendra. See, when you're considering virtualization, you always consider virtualization when you have a fairly large setup. So you may not have a SAN environment, and of course it's possible to do virtualization on local hard disks also. But like I said earlier, if you do it on local hard disks, you lose the biggest benefit of having high availability, because if your server goes down, or your hard disk crashes, or your RAID group gets corrupt, all your VMs are lost, because the VMs reside on the hard disk. So a SAN environment is cost effective for large organizations, medium to large organizations. A small organization with a small setup, virtualization, like I said, can work out to be more expensive.
All right, we'll take the last question of the day, Raymond. This is from Harvinder Singh. He says, how can we access cloud through MPLS?
Harvinder, MPLS is a simple protocol which allows you, it's for internet providers, so you can access a cloud from any internet. It's not only MPLS, even if you have a simple data card, or if you go back to traditional methods like when I started with computers of having a 56K modem, you can access a cloud. All you need is a basic internet connection. It has nothing to do with MPLS or ISDN or ILL or any of those technologies.
The rest of the questions will be answered on the site because we were short of time.
Thank you, Mr. Gagrat. The rest of the questions will be answered on the side by Mr. Gagrat. I just wanted to thank Mr. Gagrat for such an enlightening session, and a thank you to our participants also for their support in making the webinar a huge success. The recording of this webinar will be available on techgeek.com tomorrow along with your queries answered. The next webinar will be announced soon, so looking forward to seeing you next week. Thank you.